Hello Finxters and welcome back. This video is part 2 of our introduction to classes in Python. If you haven't seen part 1 and you don't know classes, I would highly suggest you start there. If you do know a bit about classes or you've already seen it, you're in the right place. So, what are we going to talk about today? What we're going to talk about is the topic of inheritance with respect to classes. And we'll introduce the parent and child terms that we use with class inheritance, and we'll use some code examples to illustrate that in action. We'll create a second child class from the one parent, so one parent, two children, and that will just start to show you the power you can unlock with classes. Then we'll discuss encapsulation, and we'll show you an example of that in code and how useful that is, particularly with protecting variables and methods within classes. And finally, we'll discuss polymorphism, and we'll create an example using our grocery items. So let's talk quickly on inheritance. We use the analogy of parent and child, and the parent class gives the inheritance, the child receives the inheritance. It's an easy way to remember what's going on. And that means that the attributes and the methods of an existing class can be inherited by the child and reused. So you start to see some power that inheritance in classes provides you. And yet you can add separate attributes and methods to the new class. And once again, you'll see this in our grocery item example that we will extend. We used it in part 1, we will now extend into inheritance, and you'll see the power of it and how it becomes extremely useful. So, encapsulation. In object-oriented programming, it's a method of limiting modification to variables, attributes, or methods within a class. And it uses a single or double underscore in front of the attribute name. And we will use that when we're doing our grocery items to prevent critical items being modified, and we'll show you how you can actually then do a discrete method to enable change, but it's one that you have to actually go in and do rather than make a mistake and change on the fly. And polymorphism, it's a term that talks about something having many forms, and in object-oriented programming it refers to using the same function for different data types. And it means the function's indifferent to the type of class. So if the method exists within the class, it will use it. And once again, you will see that with our coding. So enough talk, let's go across and do some coding. So here we are, this is where we left off in part 1. And for those of you who have made the comment about the text on the code, I hope this is a better text for you on the smaller devices that you're using. If it's not, please leave another comment and we'll see if we can blow it up even further for you. So this is where we left it, and this was a class stock for a grocery store, and we had those 4 attributes in their code description, buy and margin, which were past those parameters, stock code description, buy price and markup. And then we had a couple of methods to print out the sell price, and another one we could pass a discount to give a sale. And I'll just show you where that ended up. So as you can see there, we ended up with a retail price of $1.16 and discounted price of 99 cents. So that's fine as far as it goes. But let's now start talking about how we can make this work for us. Because if you think with groceries, grocery is a nice generic term. But if I had a can, the can is measured in volume. So it's in milliliters, in mils. If I had a lump of steak, that's weight. And steak is very perishable, so it will have an expiry date. Now, we could put all that up in here, but very quickly, if you think of all the grocery items, you're going to have a huge list of those attributes, and you're trying to second guess what you may or may not want. Whereas what we will do now is we will create some child classes that take all of this generic stuff that you're going to need for all grocery items, but then add in some very specific things that are relative to the items I've just spoken about. So let's go across and do that. So the grocery items piece is unchanged, and so what you see here, there's been no change done to that. But what I've done now is I've added in another class. In this class I've started the same way as the previous class, canned, but now instead of doing the semicolon that I would have done up there, I've got a brackets and I've put in stock. So I'm referencing the class stock, and by doing this, close bracket, colon, I'm saying that I'm creating a class which is a child of this parent. So stock is the parent, canned is the child, and what that allows me to do, you'll see me very shortly. See me code very shortly. So I've then done a category equals cans. So up here we had category equals groceries. So much the same syntax. We've done the def initialization, and so we've got all of these items here, but we're going to add in a couple of extras. So we've got all of those items, and then we've added in volume, and we've added in manufacturer. Now, this is where the magic happens, because instead of then having to rewrite all this code up here, down here, all I do is I reference the parent class, stock, dot init, and all of the parameters from there, and they will automatically then be accessible by the child, and I don't have to rewrite any of that code. The only thing I have to write are the two extra attributes that I wish to use, which is obviously volume and manufacturer, which are the ones that I had here in the parameters. So I'll pass those to these. I've also done another method which is specific to the child class. It's all very well to have a sale price, and a sell price up here, but what if I wanted with the cans to do a 2-for-1? So I've done a multi-buy special here, which allows you to buy 2 cans for the price of 1. And effectively it's 2 of whatever it happens to be, but because it's in the cans category, it'll be cans, 2 cans for the price of 1. And here you see I've instantiated it in exactly the same way as we did previously, except this time obviously we're creating an object of the class canned, whereas before it was C298 equals stock, and the parameters, it's now C298 equals canned, and all the parameters that you had previously plus the 2 extras, 400 mils and Campbell's being the manufacturer of this particular chicken soup. And then obviously as before we can call sale, which is actually a method up in the parent, and you'll see that that will be accessible and usable to us. We will also call multi-buy, which is the specific method down in the child, just to show that we can have the best of both worlds. We can use what we have in our child class, and we can also access the methods and attributes from the parent class. So let's do that now. And there you can see we have accessed the sale price up the top. The discounted price of chicken soup is 99 cents, and that comes from here, this piece of code, which is from the parent. And then we've called the multi-buy, which is this piece of code from the child, and that's returned buy 2 cans of Campbell's 400 ml chicken soup and get 1 free, pay only $1.16. So I'm hoping you can start to see the power of inheritance in that allows you to reuse something you've done before, but it provides you the flexibility of creating something new. So just to prove to you that you can do a number of these, you can have as many children as you wish, I'm going to move across to the next screen, close this down, and we'll also create another. This is all the same, so nothing up here has changed. So let's just reduce that down. And in the can stock, nothing has changed. So it's exactly the same. So let's just reduce that down. And I've created a new class now meat. And once again, I'm referencing stock as the parent class, category meat. Exactly the same as before. I've defined initialize and the attributes that are all in the parent, but now I've added a couple of extra, which is weight and use by date, because of course meat is not the same as cans. So meat is done by weight, cans are done by volume. Meat is perishable, has a use by, whereas cans have a very long shelf life. And so all we have to define under here is self-kilo weight, self-expiry use by. So those attributes that don't exist in the parent, we have to define. But the ones that do exist in the parent, we can just call stock.init. And that's where all the magic happens. You can now access all of the stuff that's up in the parent and pull that down into your child class. So I've done two methods here. One is a label, because of course with meat it's got to be labeled. It's got to give obviously the description, it's got to give the weight in kilos, and it's got to give an expiry date and obviously a sell price. I've also done a method for expiring, where meat is getting to the end of its expiry date and they want to sell at a discount, so you can pass the method expiring with the discounted amount and it will print out the discounted amount. So now we're going to create or instantiate two objects. One will be using the meat class, which is a child of stock, and it will call, we will pass those parameters to it, and one will be creating an object from the canned class, which is a child of stock, and we will pass those parameters that you saw previously. And then we will print the label using the label method in the meat. We will print the expiry discount, and we will also print the can multi-buy, just to show that the two children exist independently. They are in no way affected by having multiple children from the one parent. So let's just fire that off now so you can see what happens there. And so down here you can see we've printed the label, sirloin steak, 0.324 kilograms, expiry 15th June, retail price $6.88, and then price reduced for quick sale $4.47. So we've accessed the label and expiring methods in the meat, and we've also accessed the multi-buy from the cans class. Both of these are children of stock. We have accessed the parameters from there, and we've added new parameters in the child classes. So I'm hoping that's very clear in just how powerful inheritance is within the class structure in Python. Now I'm going to close this down, and we'll go across and talk quickly about encapsulation using exactly the same code. So encapsulation, as we spoke about previously, it limits modifications to variables, attributes, or methods inside a class. And so if we're just using the parent stock for the moment, we've got some important stuff in here. We've got a buy price, but we've got a markup. And we've set a markup. When we created that object, we said we wanted to make a margin of 1.553 on that. And so if we were to then call sell price, that would work that out. But if someone were to type in this bit of code here, C298.margin, and make it 1.2, they have immediately reduced the margin on that item. And so let's just fire that off so you can see that in action. And as you can see, retail price 116 under the margin that was loaded initially, but with the change, suddenly you're selling it for 90 cents. And so this is where encapsulation comes into its own. So we can do some clever stuff here. And so you can use a single or double underscore to say that you want to protect that item. So I'm going to protect margin. and I'm just going to put a couple of double underscores in front of each of those, and let's put a couple there just to show what happens. And let's fire that off again. And as you can see now, with those double underscores, even though we've told it to change double underscore margin and make it 1.2 from the 1.553 it won't do it. It's locked. So this is where encapsulation becomes extremely useful. And so if we want to change that, we have to have a discrete method to change it. And then this is what we have here, which is some people call a setter method. And effectively it's just another method. I've called it setMargin, and obviously the object, and I need to pass it a parameter newMargin, and then it will change self double underscore margin to the new margin. So now I'll just uncomment that. If I want to change the margin to 1.426 from 1.553, I can now call that setter method and it will make the change. And let's see that now. And so there you see the initial price at 1.553. Even though we've tried to change it by calling it directly to 1.2, it wouldn't accept the change. But now that we've called the setMargin method, which is a discrete method, the encapsulation will allow us to make the change. So as you can see, really useful method of providing some protection against inadvertent or even malicious change. Okay, so that's encapsulation. Let's now just discuss polymorphism. Now, polymorphism, we spoke about it earlier. It means that something that takes many forms, and in object-oriented programming, it means the same function can operate on different data types. And within classes, what it means is it's largely indifferent to the type of class. If the method exists within the class, it will make it work. So what we've done here, let me just show you. I've added to the canned class a label method, which we didn't have previously. So capital L label, and in it we've got the description, we've got volume, and we've got a sell price. And as you remember, we also had in the meat, we had a label which gave us weight, expiry, and sell price. So we have two methods in the different child classes, and now we've instantiated the can up there, we've instantiated the meat down here, but now we have a discrete function outside of the classes which will actually call that, the label methods within each. So I've just called it label underscore print, but I've passed it multiple arguments, the star args, so it means I can put in as many as I wish, and a little bit of code which just says for the element in args, element dot label, and we call the method. So if it will be C298, it will be C298.label, and if it's C401, it'll be the same, and it'll print those two labels for us. So let's just show that in action. And there you can see down the bottom, let me blow that up a bit for you to see better. You can see the one function has printed sirloin steak and the label that we saw previously, and it's printed a label for chicken soup, volume 400 mils, retail price 116. So this is the power of polymorphism. It's indifferent to the different classes. All it knows is it will go and find the method. The assumption is the method exists and it's the same name, and it will activate that for you. So a really powerful use within classes. All right, let's go back to the slides. So in summary, we discussed inheritance and how it relates to classes, and we talked about the parent and child terms that we use regarding class inheritance. And we showed you those examples using the can example being a child of the stock, and then the meat being a child of the stock, and how both can work independently of each other, accessing the stock attributes and methods while also possessing their own. And we talked about encapsulation, and we showed an example in our code. And finally, we talked about polymorphism, and we created an example. Encapsulation, of course, being the protection or limitation of modifications to variables, attributes, or methods inside a class, and polymorphism being a function that is indifferent to the type of class. If the method exists, it will use it. So two extremely useful pieces, particularly with regard to the grocery example that we used in this video. So that's it. Thank you very much. I hope you enjoyed both of those videos, and I hope for those of you who are having trouble reading that on your smaller devices that the larger text worked. And thank you so much for reading and watching, and we'll see you next time.